It's been a while. We haven't been using this, but so far in special relativity, you guys probably know that time changes. Um, so if you have speed equals, let me get this real quick. Speed equals distance over time, and then another one, speed equals distance, big distance over random time, right? The speed has to be the same because the speed of light is the same, and distance obviously is not the same. Then time has to change in order for the speed to equals. So yeah, so time changes. Wow, and also distance also change. And now, you want to know how much the time is changing for the outside observer or the inside observer. So we're gonna be deriving the Lorentz factor, which is just that. It's how much time is delayed for one observer. So let t equals the time light take from 0, not 0, just this, to this, which is this. And then c equals speed of light, v equals speed of the box moving, and r is time for the outside observer. So you have one scenario. This scenario is where you have a speed of light, a photon, bounces to this thing right here, and then it takes this much time. And the distance right here is just ct. So since speed of light is equals to distance over time, distance is just speed times time. So that is ct. And then now you have a scenario where there's an outside observer looking at this box, and this box is moving in this direction at velocity equals to v, or speed equals to v, and the light also bounces towards this thing. So what happens is that the light goes here, the box already moves over here, and it needs to reach this part. And what it does is it actually travels a greater distance to actually reach this part, but in the box we only see it as this. So the speed, the distance, the box traveled is this VR, since it is this, and the distance the light traveled is CR. So now you can put all of those distances together and you get a right angle triangle like this. Okay, and then using Pythagoras theorem, you can then rearrange it such that CR squared equals to VR all squared plus CT all squared. Move this over like that, and you get CR squared minus VR squared equals to CT squared. So now what you have to do, let me use another pen quick. So now what you can do is that you can rearrange this so that, well, algebraically you can get the R out, or you can first do C squared. I'll just move C squared equals R squared minus V squared R squared, and then C squared T squared. And then you can then say, well, if that's the case, then you can take the R out, and then C squared minus V squared, and then C squared T squared, and then R squared equals to C squared T squared, C squared minus V squared, and then R squared equals to T squared over 1 minus V squared C squared, and then therefore R equals to T 1 over square root of 1 minus V squared C squared. So that is the Lorentz factor.